Hi, good morning to everyone. So let us solve some numerical problems regarding to concave mirror and convex mirrors. Concave mirror and convex mirrors. Previous class we discussed mirror formula, magnification and sign convention rules and also discussed formation of an image by convex mirror, right? Let us solve some numerical problems. Before that, let us write what the formulas we have to use. So mirror formula 1 by f equal to 1 by v plus 1 by u. So mirror formula. So write the side of the paper, side of the book, the formulas what we have to use. Then magnification m is equal to height of the image by height of the object, or h2 by h1, that is equal to minus b by e. So these are the two formulas, either for the convex mirror or the concave mirror. So let us solve the first problem. Find the size, nature and position of image when an object of size 1 centimeter is placed at distance of 15 centimeter from a concave mirror of a focal length 10 centimeters. So read the problem at least twice or thrice. Understand the problem, what the values are given, what you have to find. Just by reading only one time, then solving the problem, sometimes give the wrong answer. So read the problem first. Find the size. What is the size? Nature means virtual image is formed, what real image is formed. Position of image. How many you have to find? The size, the nature and the position. Three we are able to find. Image formed when an object of size 1 centimeter is placed at a distance of 15 centimeter from a concave mirror at a focal length of 10 centimeter. So draw a rough diagram for understanding. Concave mirror. We know this is the principal axis and the geometrical center of concave mirror is pole. The distance between the pole and the focus is called as focal length f, and this is radius of curvature, the center of the curvature. Now again, so a distance of 15 centimeter from a concave mirror, and here of a focal length 10 centimeter. So here the distance between the object between pole and the focus is 15 centimeter. 10 centimeters. Where the object placed at 50 centimeter. At 50 centimeter means, is it at the center of curvature or in between the focus center of curvature? So we know center of curvature or the radius of curvature is double to focal length. So as we know, r is equal to 2f. R is equal to 2f. F how much? 10 cm. 2f and how much? 20 centimeters. 20 centimeters. So radius of curvature means the distance between pole and the center of curvature. Pole and the center of curvature. So where the object is placed? In between focus and center of curvature. In between focus and center of curvature. So if the object is placed at 20 centimeter, for example, if the object is placed at 20 centimeter, then the object is at the center of curvature, because the distance between pole and center of curvature is called as the radius of curvature. Radius of curvature. So at which place the object placed? 15 centimeter from a concave mirror. From a concave mirror. So 15 centimeter here to here, focal length 10 centimeters. So 15 centimeters. So here the object is placed. Here the object is placed. So from pole to position of the object. From pole to position of the object is 15 centimeter. That is object distance. From this object distance u equal to 15 centimeter. Object distance is equal to 15 plus or minus. So the object is placed the right side of the pole, the left side of the pole. So taken as a negative. Here object is kabatti, then all the distances measured from the pole. Right? So what is the height of the object here? 1 centimeter. 1 centimeter. So height or size of the object. H0 or H1 not to take, no problem. 1 centimeter. Then the focal length. F small f is equal to 10 centimeters. 10 centimeters. So we know object distance, height of the object or the size of the object, and focal length. Now let us calculate the size. Let us find out the values. Then first what you have to find? Position of image. Simple. Whenever you draw a rough diagram, whenever you know the position of the object, then identifying the position of image is very easy. Where the object is placed between pole and the center of curvature. If the object is placed between the pole and center of curvature, where it is forms. Let us do. So, for example, one light ray is passing through the focus, then another one through focus and form lines. It forms behind the center of curvature. Okay. Mirror formula. What is the mirror formula? 1 by f equal to 1 by v plus 1 by u. 1 by f equal to 1 by v plus 1 by f. We know that. So whenever we observe the given values, f means focal length, u means object distance. Then what you have to find? What do you have to find? Image distance. Image distance. From this, you have to write 1 by v is equal to 1 by v is equal to 1 by f minus 1 by u. From this formula, 1 by v equal to 1 by f minus 1 by u. Then substitute the values. Here, focal length also should be taken as minus f. Yesterday we discussed in the algebraic form. For concave mirror, focal length, object distance, image distance always negative. Now substitute the values from 1 by v equal to f value minus 1 by 10 minus of object distance 50. So from this we have write minus 1 by 10 minus 1 by 10. Minus into minus plus outundi 1 by 15. So that's equal to 1 by 15 minus 1 by 10. 1 by 15 minus 1 by 10. So LCM తీసుకుందాం దీనికి. ఎంత వస్తుంది LCM? చేస్తే that's equal to 30 15 2 jar 2 3 times 3. So 1 by v equal to 2 minus 3 by 30, that is equal to minus 1 by 30. 1 by v is equal to 1 by 30. 1 by v equal to minus 1 by 30. So from this you have write v is equal to minus 30 centimeters. V is equal to minus 30 centimeters. Minus 30 centimeters. So where the object is formed, what is the position of the object? The image is formed at 30 centimeters. 30 centimeters from the mirror. 30 centimeters from the mirror. So we find the position of image. The image is formed at 30 centimeters from the concave mirror. Position completed. Okay. Then what do we have to find? Size. Size nothing but the magnification. Size nothing but magnification. So position we have to find. Then magnification m is equal to there are two formulas are there. So minus v by u ఇచ్చేస్తాము, h side by h naught ఇచ్చేస్తాము. Here we have only height of the object only is there, but now we have to minus v by u. Magnification m is equal to minus u by minus v by u, because we know the object distance, we know the image distance. The ratio between the image distance by object distance. Substitute the value minus of minus 30 by 15. So minus 50. That's equal to minus cancel then 13 minus 30 by 15. 30 by 15. 15 going down, 15 to that is equal to minus 2 centimeters. Sorry. Magnification m is equal to minus 2. Magnification m is equal to minus 2. So minus 2 represents what type of image is formed? Magnification m is equal to minus 2. Then what you have to find? The size of the image. Size of the image is enlarged image form అవుతుందా or real image అనేది form అవుతుందా? Right. Size of the image. So object distance we know, magnification. Then what is the one more relationship here? m is equal to minus hi by h naught, ho. Magnification minus 2. Minus 2 is equal to hi by h naught. H naught nothing but the object. What is the size of the object? Size of the object, the height of the object is 1 centimeter. Is 1 centimeter. That is equal to, substitute, minus 2 is equal to hi by ho. Ho nothing but object. How much? 1. So finally we have to write hi is equal to minus 2 into 1. That is equal to minus 2 centimeters. Minus 2 centimeters. So minus 2 centimeters. So first we find where the image of an object is formed. The image of an object formed at 30 centimeters from the mirror. So know the position, know the size of the object. Nothing but explain about the magnification. So to measure the magnification, we have a m minus is m equal to minus v by u. We know the v value is minus 30. We have calculated, and u value minus 15 already given in the problem. Then simplification. Then we get simplification. We get magnification is minus 2. But did not ask what is the magnification. What is the size of the image? So relation between the magnification and the height of the image by height of the object m equal to hi by ho. That is equal to hi by ho. Then magnification we get 2. 2. We didn't have any units. By substituting we get minus 2 centimeters. So what about the size of the object? Minus 2 centimeters. Minus 2 centimeters. So the size of the object is 2 centimeter long. 2 centimeter long. Take a form of image. When you know the position of the object in front of the concave mirror, knowing the image position is very easy. The object placed between the center of curvature and the focus. The image is from behind the center of curvature. So we know that it forms the real and the inverted image. What is the nature? Nature of the image. Nature of the image is real and inverted. Real and inverted image is formed. Real and inverted image. And what happened? Enlarged image. Enlarged image is the size of the object equal is more than the size of the image is more than size of the object. While image height of the image 2 centimeters. Here the minus represents according to the sign convention. If the position of the object is above the principal axis positive, below the principal axis negative. Where the image is formed below the principal axis, so consider as minus. Where the object is placed above the principal axis, so it is a plus. So that minus represents objects or images real and inverted forms below the principal axis. So finally we find what is the size of the image? Minus 2 centimeters. What is the nature of the image? Real and inverted. Real and inverted. What is the position of the image? The image is formed at 30 centimeter. Formed at 30 centimeter from the mirror. So here to here we can call the center of curvature. So double to focal length 10 plus 10 20 centimeters. Then here 10 centimeters. So 30 centimeters. In this way, the problems will ask in examination. Just by changing the values, you have to practice them. So maybe they will ask the magnification, maybe ask the object distance, maybe ask the image distance, maybe ask the size of the image, nature of the image, real inverted, if it is inverted, diminished image formed, enlarged image formed, virtual image is formed. Like that, the problems will come in examination. To solve the problems, the only way is first understand first understand the sign convention rules and applying the suitable formula, then practicing the problems. Practicing the problem. When you draw the rough diagram like this, then you get an idea where the object is placed. If you know the position of the object, then identifying the position of the image is very, very easy. So the tabular form which is already given is a very, very important. And practice by changing the values. This is the first problem. Then go for next problem. So here I did not explain much problems, one or two only. Then remaining you have to practice. Practice makes perfectly. Then go for the second problem. An object 2 centimeter high. Second problem. An object 2 centimeter height is placed at a distance of 16 centimeter from a concave mirror, which produces a real image. It produces a real image 3 centimeter high. Then what you have to find? What is the focal length? What is the focal length? And the second one, find the position of image. Find the position of an image. Previous problem, height of the object is given and distance is given, focal length is given. Then we have to find the position of the image, size of the image and nature of the image. But in this problem given, position of the object is given and nature of the object is given, real image formed, object distance is given. So first of all write the given values first of all, then understand. So height or size of the object, HO or H1 equal to how much? 2 centimeter. It is positive because of it is above the principal axis. Then what is the object distance? Object distance U equal to what? Plus or minus? Minus. Always minus 16 centimeters. Either for the concave mirror or either for the convex mirror, the object distance is minus 1. Then what is the height or size? Height or size of the image. Hi equal to or H2 equal to 3 centimeters. It should be minus because it forms downward. Real image forms downward. Real and inverted downward when it forms below the principal axis. Then what you have to find? What is the focal length? And find the position. To find the focal length required to But object distance and image distance. Image is identical. So object distance only there. So we cannot get formula. Then from this formula can we find out? Can we find out the magnification? Can we find out the image distance? Yes. See, by using this formula, first of all find the position of an object. Then we get focal length. What is find the position of an object? Position of an object, where it is formed. To know, by using this formula, magnification m is equal to minus u by u. Minus u by u. But no b value. Only u. Object distance only there. Then what the formula we have to use? According to the given values, size of the object and size of the image is given. So we have to use m is equal to hi by ho. Hi by ho. Substitute object image height minus 3 centimeters by size of the object 2. So magnification m is equal to minus 3 by 2. Minus 3 by 2 centimeters. Minus 3 by 2. M is equal to minus 3 by 2. So what is the one more relationship here? M equal to hi by ho, that is equal to minus u by u. So this should be written as minus p by u. So then write like this: minus v by u equal to minus 3 by 2. Minus v by u is equal to minus v by 2. That equal to magnification. That equal to magnification. So here minus will be get cancelled out. No problem. Then that's equal. What is the object distance? What is the object distance? How much? Minus 16 centimeters. Minus 16 centimeters. So that is equal to v by minus 16 equal to 3 by 2. Minus 16 is equal to 3 by 2. So v is equal to 3 by 2. 3 by 2 into 16. 3 by 2 into 16. So 2 1 jar, 2 8 jar. 2 1 jar, 2 8 jar. That is equal to 8 3 jar, 24. 8 3 jar, 24. So how much? What is the image distance? Minus 24. So magnification here minus the magnification minus. So simplification is a little bit confusing because we have to follow the sign convention. So plus minus plus, and then you have to get idea about sign convention rules. Sign convention. So magnification m is equal to hi by ho, that is equal to minus v by u. So height is minus 3. Object 2, that is equal to minus p by minus 16. Then 16. So here minus cancel because of, okay. Then v by 16 equal to minus 3 by 2. V by 16 equal to minus 3 by 2. From this, v is equal to minus 3 by 2 into 16. Minus 3 by 2 into 16. So 2 1 jar, 2 8 jar. Then v equal to 24. Then v equal to 24. So what is the position of an image? Position of an image is at 24 centimeters. At 24 centimeters from the middle. Okay. Then what about the focal length? So for finding the focal length, we use the formula 1 by f equal to 1 by v plus 1 by u. That's equal to object is image distance minus 24. So 1 by minus 24 plus of object distance minus 60 by minus 60. So that is equal to 1 by f equal to minus 1 by 24 minus 60. So simplify essay వస్తుంది 48 LCM 24 2 jar minus 2 24 16 3 jars minus 3, that is equal to minus 5 by 48. Minus 5 by 48. Very 1 by f equal to minus 5 by 48. So then from this you have to write f is equal to minus 48 by 5. Minus 48 by 5. Whenever we simplify it, we get minus 9.6 centimeters. So approximately 50 and then become 10. So focal length is minus 9.6 centimeters. Minus 9.6 centimeters. Then in this way we have to find the position of image. Then focal length of the image. So what is the magnification? Minus 3 by 2. Minus 3 by 2 and then we get minus 1.5. Minus 1.5. What is the size of the object? 2 centimeters. So magnification minus k. Then what about this size of the image? 3. So size of the image is more than the size of the object. So real and inverted image is formed. Where it is false. So object distance minus 16 centimeter. Focal length minus 9.6 centimeters. So approximately diagram practice here the focal length how much? 9.6. Focus 9.6 and 9.6. 19.2 here the center of curvature. Where the object is placed 16 centimeters. So here to here how much? 19.2. 19 point radius of curvature. Center of curvature to pole distance is 19.2. Where the object is placed 16 centimeter. 19.2 and in between the focus and the center of curvature. In between the center and center of curvature and the focus. So where the image is formed? Behind the center of curvature. So here the behind the center of curvature the image is formed. In this way you have to calculate, you have to find the given values. Numerical problems very important. So in examination point of view, to solve the problems, once again I am telling you sign convention rules. Sign convention rules must be keep in mind, because giving the plus or minus for the object distance and the image distance. Then position of the object and the position of the image. So keep in mind the sign convention rules, apply the suitable formula, understand the given values. When you understand the given values, then you get the idea which formula you have to use. So and the positions of the object. When you know the position of the object, then it is very easy to know the position of the image. So two problems are regarding to the concave mirror. Then let us discuss one more problem. Right. A concave mirror, the third problem. A concave mirror produces 3 times magnified real image of an object placed at 10 centimeters in front of it where the image is located. Where the image is located. So try to solve this problem. Right? See, magnification m is given in this problem. What is concave mirror produces 3 times magnified real image. A concave mirror produces 3 times magnified image. So magnification is given. Magnification m is equal to -3. Then where the object placed 10 centimeters. Object distance u equal to -10 centimeters. Where the image is located. Then what we have to find? Image distance. V equal to magnification given, object distance given. Then what we have to find? Image. By using the formula, m is equal to minus v by u. That is equal to, from this formula we have to write minus v is equal to m into u. That is equal to, so minus v is equal to magnification -3. Magnification is minus because of real image is -3 into object distance -3. Object distance -3. So that is equal to -30. That is equal to -30 centimeters. The simple problem. No problem. So these are regarding to some numerical problems also.